alone, no problem. So I have started similar triangles, and I have completed basic proportionality theorem, and I started exercise also, exercise of 6.2, and I did 2 problems. Yeah, I did 3 problems I did it, and more 6 problems I have to do. I'm going to do today, and after that I'm going to start the next part. But before I start, I wanted to tell you something. Similar triangle is one of the important chapter, because small chapter. As per the blueprint, definitely a question comes from this, 2 questions from this, and most of the students feel that it is a difficult chapter. Yes, those who are not having a geometrical foundation, and definitely it is a problem for them, but there is no other go. If you want to get good marks, definitely you have to go through this. Pythagoras theorem is removed, only basic proportionality theorem is there, and few questions are there. That's it, not very much. So if you just focus little, then you can get through this chapter. Now I have to do question number 4. Question number 4. Figure is already given. Question number 4, figure is already given. And let me start. 4th question, exercise 6.2. So this is I'm going to do it. So DE is parallel to AC, DF is parallel to AE. So a triangle is already given. Let me draw a triangle. In my thing, I will get an equilateral triangle only. So because I am using paint to draw the figures. So A, B, C is the triangle, and in this DE is parallel to AC. So there is a DE is parallel to AC. I will take a line. DE is parallel to AC. So this is DE. Even you also, when you are doing the problem, you read the problem one by one and draw the diagram. Don't just simply copy from the textbook. When you are drawing, you should understand it and you should draw it. So DF is parallel to AE. Now I have to join AE. This is AE. Okay. And then DF is parallel to AB. this is the parallel line to AE. So now this is F. Let me indicate parallel symbols so that you will understand. In your mind you will get a map. So this is also parallel, 2 arrow marks showing 2 arrow marks, both are parallel. So I told you, you can apply basic proportionality theorem when there is a triangle and when there is a line parallel to one side. So in RTP, what RTP I have to do? Okay, prove that BF by FE is equal to BE by EC. This is what we have to prove. So let us see BF. Where is BF? Yeah, this is BF. And FE, this is FE. Okay. And where is BE? This is BE. And EC. Okay. So that means all these parts are there on the base only. So now let us start the proof. I told you, let us take one triangle. Triangle ABC. You take triangle ABC only. And in triangle ABC, DE is parallel to EAC. Okay. So then by basic proportionality theorem, let me write BD by AD is equal to BE by CE. This is using basic proportionality theorem. Let us say this is first equation. Now one triangle we found, one triangle, one line parallel to one side. Now there is one more line parallel to one more side in one more triangle. That triangle is ABE. Triangle ABE. DF is parallel to AE. So AE is the side and it is parallel. So therefore you can apply again BD by AB is equal to BF by FE. So this is also basic proportionality theorem. Second equation. Now I have applied basic wherever I can apply basic proportionality theorem in this figure, I have applied it. Just if you just see, compare first equation and second equation. Okay, these right hand sides are, left hand sides of both the equations are same. I'm sorry, here I have to BD by AD, not AB. So left hand sides are equal. So therefore right hand side of 1 is equal to right hand side of 2. Okay, so then what is right hand side of 1? B by CE is equal to, what is right hand side of 2? BF by FE. This is what is to be proved. Only sides are changed. I'll write it. That implies I'll exchange the sides. BF by FE is equal to, and BE by CE. This is what is to be proved. Okay. Now very simple. I did not do anything. I just applied basic proportionality theorem. So that is why it is very important how to apply basic proportionality theorem in a triangle. So let me go to another question. Okay. Question number 5. Figure is given. Question number 5. Figure is given. Page number 85. Okay. I am not drawing. This is exercise 6.2. So D is parallel to, I'll write given. In my previous problem I did not write hello Kushi, good morning, where are you from? Given D is parallel to OQ. I am writing as per problem. I didn't draw the diagram. I am going to. Class 9 starts at 6:30. Class 9 starts at 6:30. Please join at 6:30 class. Okay. Bye bye. So TE is parallel to OQ and DF is parallel to OR. This is what is given, and you have to show that EF is parallel to QR. So it is asked to prove two lines parallel. That means converse of basic proportionality theorem you have to apply, I think. Okay, let me draw the diagram. So here also PQR triangle is given. I will draw a PQR triangle. I told you I will get only basic equilateral triangle. I am using paint. So PQR, a big triangle, PQR. You have to draw the figure using the scales and hello Aryan, good morning. So PQR, if you draw the diagram using trigonometry, Aryan, I have already taught. You can refer back my previous online class videos. Okay, after trigonometry only I have started this. I have already taught. You just go back and refer to my previous live class videos. They are available in YouTube. Subscribe it and share with your friends and enjoy learning. Okay. So anyhow, my my mobile video has stopped. I'll go through the PQR, and then DE is parallel to OQ. Where is OQ? OQ I have to draw. O is somewhere here. This is O, and I have to draw join OQ. And he joined OR also, and he joined OP also. Okay. So, and then let us start. D is a point on PO, and DE is parallel to, yeah, this is parallel to OQ, and DF is parallel to OR. D same, DF is parallel to OR. Let me put the parallel line, parallel symbols. These two are parallel and these two are also parallel. If you indicate parallel symbols, it will be very good for you. Okay, you can have a view and vision of the problem. So then there are two triangles. Apply basic proportionality theorem. Okay, so now EF is the middle line. EF is parallel to, let me join with red color, this EF is parallel to QR. So diagram is not drawn clearly, it's okay. So this EF is parallel to, this is D and this is E and this is F. So now let me start proof. In triangle PQOR, POQ, DF is parallel to OQ. This is given. Therefore, let me apply basic proportionality theorem. Basic proportionality theorem gives that PD by DO is equal to PE by QE. Basic proportionality theorem, first equation. Take another triangle, other side, right side triangle. Triangle POR, DF is parallel to OR. So then PD by DO is equal to PF by F. This is also by using basic proportionality theorem. Second equation. So then again you compare first and second equation. So then what happened? LHS of 1 is equal to LHS of 2. Both equations LHS are equal. Therefore, right hand sides are equal. So what are the right hand sides? PE by QE is equal to PF by FR. So PE, QE are these two things and PF and FR are these two things. So that means by converse of basic proportionality theorem, EF is parallel to QR. This is what is to be proved. Okay, so here converse, if a line divides two sides in the same proportion, then it is parallel to the third side. I'll just draw and I'll show you what is converse of basic proportionality theorem. This is a triangle. Let me name it ABC. So D and F are 2 points, D and E. So AD by BD. We don't know whether DE is parallel to BC or not. But we know this DE is dividing the two sides in same proportion. AD by BD is equal to AE by CE. So if a line divides two sides in the same proportion like this, then that line is parallel to the third side. This is converse of basic proportionality theorem. Okay, I have applied the same thing, PE by QE and PF by FR. Therefore, EF is parallel to QR. Okay, this is how question question number 5 goes. Question number C also, it will be like that. Question number 6 also. I hope you can do question number 6. At this point, I'll stop my lesson. Because I'm taking only 15 minutes. Very less number of people are there. These problems, I'll do it and I will release a video. Okay, remaining problems. So tomorrow I'm going to teach, because 10th question is very important. Trapezium 9th and 10th questions are very important, right? I'm going to teach separately a video. I'm going to make a video and I will release it. So if you subscribe my channel, these extra exercises videos, you can see it and you can learn it.